Math 1332, Chapter 3, Symbolic Logic, Section 2, Truth Tables, Video 10. Truth Table Example 5, 3 simple statements. I believe that is the correct number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, okay. Sometimes when I start the next video, I forget to change numbers on top. Anyway, so we're going to construct a truth table for the compound statement P and Q or negation R. And we're going to do it the same way we do all of them. First, we're going to determine the correct order based on the hierarchy. According to the hierarchy, where do we go first? Inside the parentheses, and there is only one connective inside the parentheses, so that will occur first, which will conclude the parentheses, so we move outside of it, where we see a disjunction and a negation, and which of those takes precedence? Negation happens first. Disjunction happens next, so the disjunction will happen last. It is imperative that you nail the correct order. I can't stress that enough. I've already got a truth table set up for this particular compound statement. Let's make sure that I wrote the compound statement correctly. I did. And I've already got the first 3 columns populated. I do want to remind you that because there are 3 simple statements, there are a total of 8 rows, because every time you add a simple statement, it doubles the number of rows. For a better explanation as to why the first 3 columns are set up the way that they are, please go rewatch the previous video. I will remind you of one quick gimmick though, that when you have 3 columns, the rightmost alternates between true and false. The next column to the left alternates but in groups of 2, 2 true, 2 false, 2 true, 2 false. And the next column to the left, that also alternates, but the group size double. So instead of two trues, it doubles to 4. 4 trues, 4 falses. If we add another column, it would double again, but we will not encounter compound statements with 4 simple statements inside of them. All right, so based on our hierarchy, we know that we are going to do the conjunction first. This guy right here. So let's write a first column for that. Our first column will be conjunction, the left of which is just a P, the right of which is just a Q. We know how wide the column is, so let's go ahead and draw a vertical line to separate it from the next column. And what is the rule for conjunction? You need to know these rules. The rule for conjunction, it's true only when all T's. So that is the rule that we're going to do. Now, since we are building the column around the conjunction, we need to find the columns prior to which we apply this rule. To the left of the conjunction is the P, which is this column here. To the right is the Q, which is this column here. We're not looking at the R column, it's in the way, so I'm going to cover it up. Don't scribble it out, we'll need it later. Cover it with a pencil, finger, paper, whatever. And now we have to play out this rule that was not supposed to be covered up, that was supposed to be highlighted. We're going to play out this rule to these 2 columns. So, in which rows does this rule apply? In which rows are there all T's? This row. Any more? This row. Any more? That's all. Those are the only rows in which the rule applies. Those are the only rows which are all T's, which means in the current column, we're going to fill out with true. Since those are the only rules that since those are the only rows that this rule applies to, those are the only rows where we write true. That means the rest of the rows we write false. All right, let's clean this mess up. All right, the second column is going to be built around what? According to our hierarchy, the negation was next, and a negation always belongs to the thing immediately to the right of it. This negation belongs to that R. So our next column is just going to be a negation of R. This should be a pretty easy column. Let's go ahead and separate that column from what will be the last column. But for the sake of consistency, what is the rule for negation? Negation changes the truth value. So we need to change the truth value, but change the truth value of what? This negation belongs to that R. So we need to apply that rule to the R column. We have a lot of columns that we're not looking at, so let's cover them up just for a second. And I forgot to write second above this column. I thought I had. All right, so we will apply this rule to this column. So just change them all. Well, look at them. They alternate starting with T. So when I change them, they will alternate starting with F. False, true, false, true, false, true, false, true. Negation is usually pretty easy. You just got to make sure you find the correct column to change the truth values. And let's clean up this mess. And to the next column. The third column was built around the disjunction. Excuse me, still got it in eraser mode. The third column was built around this disjunction. To the left of this disjunction, immediately to the left is a closed parentheses. And so the left of the disjunction is that parentheses and its contents. To the right of it is negation, which belongs to an R. We are going to use, let's use green this time. Let's use brown. I don't use brown very often. Okay. Next, since we are building the column around disjunction, we need to know the rule for disjunction. And what is the rule for disjunction? The rule for disjunction is false only when all F's. So that is the rule that we need to apply. To whom do we apply it? Let's see what's on both sides of the disjunction. On the left of the disjunction is a closed parenthesis, so the left side is that parenthesis and its contents, which means this column. The right side is a negation, which belongs to the R, and the negation R column is over here. Even though they are not obstructing our view, I'm going to cover up these guys because we don't need them for this last column. And now we just have to find the rows that this rule applies. In which rows do we have all F's? See if you can find them. There's 3 of them. Row 3, row 5, and row 7 all follow the rule, all F's. So those 3 rows are the only rows where our final column will be false. Since the rest of the rows don't follow that rule, the rest of the rows are not false, which makes them all true. Let's clean this up. And just like that, we have our completed truth table. Hopefully you're starting to see that these are fairly predictable. You set up your columns and your rows based on the hierarchy, the number of rows based on the number of simple statements, the number of columns based on the number of simple statements, and the number of connectives and negations in the, compound statement. And I should warn you that it's not always just number of letters plus number of symbols. Sometimes it's a little less, actually. For example, and it didn't happen here, but just to kind of show you what I mean, if for some reason there was a giant parentheses around here and it was pointing to negation R, well, notice that this negation R and that negation R are exactly the same, which means that we would not have to have a separate column for each one. We would only have to have it once. But a good rule of thumb is number of letters plus number of distinct letters plus number of connectives and negations equals total number of columns. Sometimes it's a little less though. All right, we're going to do one more and then a follow-up video after that to show you that sometimes we don't need an entire truth table.